Hey guys, welcome to Unit 8A, more differentiation rules. Our topic today is derivatives of inverse trig functions. We've already seen the derivatives of trig functions. Today we're going to be doing inverse trig functions. What is an inverse trig function? We write it like this. Trig, like let's say sine is your trig function, so sine inverse of x. Or you might see me write it like this, arc sine of x. They both mean the same thing. Pause the video and try the warm-up. The warm-up is asking you to find the limit of this function. Okay, this is difference quotient. We did this a while ago when we learned about limits. Remember, it was, I'm going to go back to the original, minus f of x over h. Do you agree this was your original function? So if I look at this, the function has been substituted. Isn't this my f of x? So I already know I don't have to do the whole long thing, expand it and all that. I already know my f of x is tangent x. Now since we know derivatives, tangent x is what? Secant square x. So you didn't have to do a lot of work here. Okay, so it's asking what if you were asked to find the limit of this. So now look again. What am I substituting x with? Pi. So I already know my f prime of x is secant square x. So what would be f prime of pi? So the derivative of that would be, I'm just going to rewrite this. The square is on the outside. Secant pi is -1. Secant is, remember, the reciprocal of cosine. So cosine pi is -1, so is secant pi. So -1 squared, which is 1. Okay, so now, before I give you all the 6 rules of the inverse trig functions, I just wanted to derive the first one with you. We're not going to derive all of them, but I just want to do one of them so you kind of see where it's coming from. So let's get started with that. If you want to pause and try it on your own and see, that'll be good. Otherwise, let's go. So remember, it says y equals arc sine. Arc sine is same thing as sine inverse of x. Okay, so I'm going to be using arc sine. So how do I undo arc sine? I'm going to take sine on both sides, right? So if I take sine on both sides, and sine and arc sine will cancel each other out. They're inverses. So that would be, this cancels, so I'm left with sine y equals x, or x equals sine y. So I'm going to take the derivative with respect to x. So I'm going to actually switch sides, or I'll just keep it like this. So derivative of sine y is cosine y, and given my chain rule, it'll be dy over dx, right? Then the inside equals 1. So if I was to solve for my dy over dx, what do I get? 1 over cosine y. So now I need to relate this y back to x. Let's write that down. Relate to x. So how do I do this? Remember our Pythagorean identities. Sine squared y plus cosine squared y is equal to 1. If I solve for cosine, what do I get? I get 1 minus sine square y, right? So can I substitute my cosine y with this? So I'm going to substitute that in there, which would be dy over dx equals 1 over 1 minus sine square y, right? I already know my sine y here. My sine y is what? X. So sine square y will be what? X square. So dy over dx is equal to 1 over 1 minus x square. Square root of 1 minus x square. So that is the derivative of arc sine of x, right? Similarly, you can find the others. You would end up using Pythagorean identities. I'm just going to give you the rules here. So arcsine is, we just did that, 1 over square root of 1 minus x squared times the derivative, whatever the inside is, right? So here it's x, which would be just 1. So I just want to write that down so that sometimes we forget, again, your chain rule, right? So 1 over arctan is, the derivative of arctan of x is 1 over 1 plus x squared, and times the. So I wrote out the remaining, and if you noticed, I also wrote x prime. I can substitute x prime with is 1. So I don't want you to think too much about it. It is basically the derivative of x is just 1. So either you can choose not to write it, or when you're taking the derivative, remember, you must take the derivative of this argument also. So that's basically it. Let's get started with the example. Oh, before I go over the example, I just want to talk about it. Again, just like your trig, the regular trig functions derivative, the inverse is all your functions that start with c's, cosine, cotangent, and cosecant have a negative. And if you see, they're very similar. It's the same thing except they're plus and minus, right? If you look at tangent and cotangent, they're the same except plus and minus, even for arcsecant and arccosecant. Okay, I just wanted to also bring this up because that confuses people a little. What is this part? This is the absolute value of x, and when you derive it, it has to do basically with the graph of your secant function and its inverse. So that is the reason why there's an absolute value. Since we are not deriving these, just memorize it that it is an absolute value of x for both the arcsecant and arccosecant. Okay, so let's get started with our first example. So basically you need to know these rules and apply them, and then simplify and write your answer in terms of x. So it's telling me to find the derivative, so my y prime or would be what? This is my y, right? So it would be the derivative of cosine inverse is what? Since it's a cosine function, it's going to be negative 1 over, and that is square root of 1 minus x squared, right? So 1 minus, what's my x here? It's x over 2, so x over 2 squared, times, what did I say? The derivative of the argument, right? So in the above questions that I gave you, the rules, x was there, so it was just times 1. But here it'll be what? 1/2, right? Because x over 2 is same thing as 1/2 x, so derivative of that is just 1/2. So let's do the next step. Let's simplify this a little. So y prime equals, I'm going to simplify the denominator. That's what I really need to simplify. Negative 1 over, can I put the 2 here? And this would be what? This simplifies to x squared over 4, right? And if I take the LCM, I get 4 minus x squared over 4. This is all over the square root, right? Which is same thing as, I'm just going to do the denominator. 4 minus x squared over square root of 4, which is what? 4 minus x squared over 2. You can choose to skip these steps if you understand it, but I just wanted to show it because sometimes it can get confusing, especially when we're learning it for the first time. So negative 1 over 2, and can I not factor out the 2 over 2? 4 minus x squared, which would be what? I'm going to actually do it in the next step. So y prime is negative 1 over 4 minus x squared. Okay, so it's just simplifying, knowing your rules up above. So now it's talking about the arctan. If you want to write it, I'm going to write them on the side. Remember, your arctan is 1 over 1 plus x squared. So let's do this. So this would be what? Can I rewrite this as 1/2 y is equal to 1/2 arctan 4x, because that'll make it so much easier, right? I don't want to put the 4x in parentheses if that helps. So now y prime would be what? 1/2. And this will be replaced with this, right? Remember, your x is 4x here. So this would be 1 over 1 plus 4x squared times the derivative of 4x is just 4. Let's simplify this. I get this cancels out. So I'm left with 2 in the numerator. So 2 over 1 plus 16x squared. So there's not much to do except for the algebra that can get crazy. Other than that, just know your rules, write them out, and they're very similar to each other. So good luck, guys. Finish the lesson and